Hello, hello. Um, Sorry for the break. It was 3 days, I think. I wasn't streaming. Um, so yeah, I wasn't able to stream, but I was able to code. So today, I'm actually gonna go over what I did those 3 days, and maybe I'll try day 11. I don't think so, but I'll go, I'll go if I'll go over it fast enough, then maybe I'll see. Um, I don't know if you can see when I'm in my pajamas because it's more comfy. I'm too lazy to actually switch to fine. Right, it's fine. um, let's start with day 8. Day 8 was Haunted Wasteland. I think so, right? Wasteland. Yeah. Okay. About this, part 1 already did. Part 2 I was not able to. Um, and I got a lot of help with it. There's no way I would have solved it alone. But um, let's go over the code and try and explain what I have, what I did. Um, First of all, I'll go over what I was supposed to do. Okay, this is the input. I was I'm giving a set of instructions here all the way. Um, and I have these nodes. I don't know how to call it, things. So I have my I have NQT, for example. Oh no, sorry. I'm supposed to start on part 1. I'm supposed to start from AAA. My starting position. I don't remember where is it. I don't know. Anyway, doesn't matter. I'm starting with AAA, and including AAA, each of these have like 2 values. So this is the left value, this is the right value, and I'm going like, let's say this is AAA, okay? So um, let's say this is it. So the first instruction is go left. I'm going to TXC. Then I'm going to the next instruction. In TXC, I'm again going left. Whatever after that, I'm going right, and so on until I reach the end of the instructions. uh, and I'm doing this until I'm not on ZZZ or ZZZ. I don't know how you. Um, so this, and then I go over these instructions. When I reach the end and I'm still not on ZZZ, I'm just looping again over it. So again on L and so on. That was part 1. How I did it was it? This is the parse input. I have current line. The first line is instructions. Then I'm going another line, and here another in a while loop already. Um, Current place is basically current place. This it's this is the whole line I get, and I have 0, 1, 2 here. So I'm grabbing a substring of the current line from 0, length of 3. Left direction is this this starts at 7, and again it's the length of 3, and the right one starts at index 12, and again it goes 3. Directions at current place. The directions are error. Oh, sorry. Um, I have instructions, which is just single line. I'm getting here, and I have a map. Inside the map, the first value is this, the place I'm currently in, and then the second, like the key, is the first I'm in, and the value is a pair. The first one is left, and the second one is right. And that's it. And I'm just pushing, saying directions at this place. This key equals to this pair. And calc num of steps part 1. I'm sorry, there's a helicopter above me. I don't know if you can hear it, but there is. It's going away. So I have my instruction string, I have my direction map, parsing input, other one. That's cool. Number of steps. Oh, I have to calculate the number of steps took me to go from A to Z. So A is going left, I'm going left, this going right, each one of them going left is one step, then going left again is another step, and so on. Until I reach ZZZ, then my output's supposed to be the amount of steps I took. Amount of Z bust, that's part 1. Oh, sorry, that was for, I don't need this. That was for debugging for part 2, I think. But here basically I have switch, I have instruction index, so where I am at my instructions, which instruction I'm on. So that's a do while loop. While amount of z passed is less than 1. This is not needed for this because basically this tells me if I in a z, then a z at the last. Yeah. So basically when I say this once, then I am increasing the amount of z I just in, but I just need to reach it, so as long as it's 0 basically, less than 1. So this while loop will go until I reach my goal. So switch my current instruction left, case it's an L, then I am, and current place will be now my map at current place dot first. So current place is the key, so, and it's value of left and right, so the first is the left value of that. Same here, but second is the right value at the pair. Default is not supposed to get here, so I have error message. That's not actually, but I have a message. Okay. This if I sin triple Z, then I passed it, so I increase it. Number of steps I'm increasing because I just took step. Instruction index I'm increasing. If instruction index, it's not supposed to be more, but it can be. It will be equal to the size. Still, I did that. Again, that doesn't matter. So if it is equal to size, then it is actually 1 after the limit, because the last index is size minus 1. So I'm resetting it, and if I didn't find triple Z, then I'm continuing this loop until I do, and returning the amount of steps. So this is the that's it for this part one. Part two is where it got hard. Now, technically, it could run basically the same algorithm, a slight change. It will just take me long time. Like I didn't even wait until the end. Yeah, I didn't brute force it. So first of all, what am I supposed to do now? I have ghosts, okay, and each of them starts on uh, string. Like it's always three characters, right? So each of them starts on a different string that ends with A. One of them will be A, but it doesn't matter. They end on A. And they all follow the same instructions. They just start from different places, and they all like move at the same time. And I need to calculate when each of them will be at a string that ends with Z. So not triple Z, ends with the Z. Okay. Uh, Now problem is, well, problem is it's slow. Okay, and takes just it's too long. Uh, because he did a little trick that again without help I couldn't have gotten it. Understand the trick or even where to look to find the trick. But yeah. So and the ghost, I don't remember if I said it, but the ghost supposed to they start on different strings, each of which starts ends with A, and they have to end on different strings, each of which end with a Z. And on the input it's six ghosts, right? So I have to wait until all of them end on Z at the same time. They move at the same time, and I have to wait until all of them end up at the same place at the same time. Not the same place, at different places that end with Z. Okay, so I'm not even sure I'm using all of those functions. It was a messy, it's a messy code, but I didn't got around to fixing it. I never have the, I never have the mental capacity. I guess I just don't want to. It's boring to get to try and fix my code. I know it's important, but I didn't got around it yet. I'll try to fix it sometime. Sometimes. So here I have now a vector of ghosts. Okay. Um. Each ghost. Each ghost is has two values. First one is string, so it's current location, I think, right? If I remember correctly, and this is the number of steps each of them took. I have a boolean vector of booleans is z seen by ghost. I'll explain it later. Instructions, directions. This is the same of direction, string of instructions. I'm parsing inputs same as part one on direction and instructions. And now for each direction in directions. So Um, First is the key, so it will be the key, not the pair values. It will be a singular key. So each direction first at 2. So I know string is always at length of 3. So the last letter will always be at place 2. And I'm checking if it ends with A basically. If it is, I'm creating a new ghost basically and pushing here a pair of direction first. That's where it stands right now, and 0 the amount of steps. So still didn't took any steps. That's on initializing it basically. So I'm going. Um, I can optimize it a bit because it will go even after. I actually can't. I don't know the amount of A's. I have to go through all the keys in the map. Build a vector with all ghosts that ends with A. Places that ends with A. Here, um, initializing is is Z seen by ghost. Probably I could have done here maybe or something. I don't know, but I'm basically creating a false for each ghost, and index in this is equal to the same ghost here. Um, I could have maybe created, I don't know, a tuple or a struct or whatever, store it in this instead of a pair, but uh, it was. I hate tuples and I don't know about structs. I mean, I know about structs. I didn't want to. I just did that. Um, Instruction in, because this is the same as part one. Here I have are all true. Basically, for now, for this while after this, I'm doing some more calculations. But for this, I just want to basically count the amount of steps a ghost. It's took a ghost to get to his destination, to the Z with to the place with the last where the last character is Z. And basically, when a ghost sees Z, it will actually turn at the same index. It will turn into true for him. So he now seen a Z, and I don't want to keep moving him anymore. I'll explain. Actually, explain now. So basically, the catch thing that was annoying about this question. Also, I had some problems after I got the trick. After someone explained me the trick, something different. Basically, uh, when I get it's based on the input. When I get to the input is built that way that when a ghost gets to destination, first time it get to um place where the last letter is Z letter. Yeah, letter. So when it gets that, then it actually takes um a loop. Does the same thing again. Goes again the same route. So basically, the ghost that starts on A and probably ends on ZZZ. I didn't check that. So, but let's say that's the route. He starts on the AAA, triple A, and ends on triple Z. He takes this route, and first, how to say it? First, uh, instruction. The first instruction on Z, the left and right is same as left and right of triple A. And the instructions are built that way, so I want to go left when I reach triple Z, but I was going right when I was starting a triple A. taking left triple Z, and I'm doing the same route again and again and again. So basically what happens, I'm just running this simulation until it satisfies the condition of uh, every ghost being on a place that ends with Z at the same time will take a long time, because one ghost reaches Z, other ghosts are not on another place on their end destination. And each of those ghosts, by the way, goes in a loop. Yeah. So um, yeah, basically they are going and repeating themselves. So one ghost takes him like 13,000 steps. The second ghost takes him 20,000 steps to reach his destination. So basically, have to overlap. What needs to happen is it also took me quite a long time to understand, even after I got the catch. Right. Um, what needs to happen is I know that all ghosts are on their respective places. Is if I know that one loop takes them 13,000, right? And the one's 20,000. So I need to know that both of those ghosts gotta be at their end of the loop. So this gotta take 13,000 steps, and the other one gotta take 20,000 steps. So at the first run, it won't happen, and won't happen for maybe quite some time, or maybe it will. I didn't calculate that. Okay, so yeah, and it takes a long of time. None of them are going to. None of them are gonna stand on their end goal after like a couple of loops. It will take a long, long time. Especially when I gotta take into account that I go through those 6 ghosts each run. It takes time. So anyway, what I did is counted one loop. So if it's left, then each ghost now goes left basically. So ghosts. So I'm going through the ghosts. So the current ghost first. So his current location, his the map directions, and I'm giving it again the location, produce me the values, and first, right? So the left value. Same with right, just here's the second break, and here at the end of this, after the switch case, basically, I'm going through the ghosts again, and if Z not seen by a ghost, then I am increasing step for each one of them. Then I'm checking, are ghosts on Z? If they are, if where is it? Here. Here I'm basically getting the ghosts and the vector, so I can update the vector, go through the ghosts, and I'm checking if current ghost is last letter is Z. If it is, then is Z seen by ghost? At this place, ghost is true. And here, basically, is it? So yeah, here if it's true at any of them, it will not update the the amount of steps it took for each ghost to take, but for the current ghost to take, because you already reached this destination, and I know the amount of steps you have to take to get a full loop. And yeah, this is the instruction. I'm updating it. So here, where's the while? All true is basically I'm checking if every value at this vector is true. If every value on this vector is true, then I've seen that I know that every ghost go to their destination. Okay, after I counted that, I'm taking number of steps. Uh, for now, it will be the maximum number of unsigned long is a lot. And amount to add is, well, I'll explain it in a second. Here I go for each ghost, and basically number of steps will be the minimum. Um, I'm grabbing the minimum amount of steps one of the ghosts took to get to his destination, their destination. So for each ghost, for ghosts, um, can be const, I think. Max values, rank ghost second. Do I need this? Yeah, I call it max values. It's basically the amount of steps each ghost took. So I'm just setting with while um not check for module of max values number of steps. I'll get to that. I'm adding the amount of steps. I'm adding amount to add to the amount of steps. So I can't do amount number of steps add to number of steps. I'm just gonna be multiplying by 2. I want to add a constant amount to number of steps. So this is why it's equal to this, but it will not be updated when this is updated. So what is this? Max values are again ghost values, the amount of steps they took. Number of steps is current amount of steps I am taking. So this is check for module. Basically, I go for each step in steps. Okay, these max values, and I'm checking that the number of steps modulo current step is not equal to 0, false. So if current amount of steps that I got to is not divisible by each one of the amount of steps it took for each ghost, then I want to continue this while loop. Why am I doing this? Because calculate the amount of steps I took. I know that I have to get, like, I know there will be the same number, like the same amount of not the same number, sorry. There will be at the end where the amount of steps I took to get to the end of the amount of steps I took while they were looping and all is they're all divisible by it. And I'm adding each time I'm adding the minimum amount, so the minimum amount of each ghost of the all ghosts. One of them took some minimum amount of steps. I'm adding this to my current amount of steps that I'm calculating, and this gets me to the solution because if I got to some place that all of those are divisible by it, or it is divisible by all of the steps, then I know finally got to the place where all of them I got the number of steps that took each of them to go, and including each loop they took. This is a huge number, but and it takes on release mode about 20, 21, 24 seconds. I'll run it and I'll show you. But this is a solution. Number of steps. I'm turning this. Let's go to main. This is on the wasteland. Uh, this, this. I'm gonna run it and change. It might actually take more time because this is the first time I run it. As far as I understand it, it takes like it didn't cache anything or something like that. Don't really understand this, but it may take a bit more time. Maybe I hope like no more than half a minute, 40 seconds. It still takes a long time. It's a huge number, and I'm still adding 30 seconds. This is the number. Uh, yeah, so it's fucking slow. It's 30 seconds, but um, that's the best I can get. At least it's not like an hour. Um, by the way, this is actually an algorithm that is called LCM. I think something in a started library can take care of this, and it will be much faster. But this number let me compare it actually. The answer I gave it. It's not. I didn't change it, so it's supposed to be. It's the same number. Okay, so that was 8. Let's get to 9. Actually, here. Bookmarks the way. Okay, so let's go to day 9. Gonna read it. Whole thing. Okay, whatever. I'm gonna read it. So, Mirage Maintenance. You ride a camel through the sandstorm and stop where the ghost's map told you to stop. Sandstorm subsequently sides somehow seeing you, standing at an oasis. Camel goes to get some water, and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. That must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises up and heats up the sand, you might be able to use the glider and the hot air to get all the way to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of the desert island. Must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Your puzzle input. Each line in the report contains a history of single value. For example, 0369, all that. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. In the above dataset, the first history is 0, 3, 6, 9, 12, 15. Because the values increase by 3 each step, the first sequence of difference that you generate will be four threes, or five threes. Sorry. Note that this sequence has one fewer value than the input sequence because at each step it considers two numbers from the input. Since these values aren't all zeros, repeat the process, the value differ by 0 at each step, so the next sequence is more zeros. This means you have enough information to extrapolate the history. Visually, these sequences can be arranged like this. So, yeah, 3 minus 0 is 3, 6 minus 3 is 3, all 3, and then 3 minus 3 is 0, and so on. Extrapolate start by adding a new 0 to the end of your list of zeros. Because the zeros represent differences between the two values above them, this also means there is now placeholder in every sequence above it. So basically I have to get this. This will be my answer. You're gonna start filling in the placeholders from the bottom up. A needs to be the result of increasing 3, the value to its left, by 0, the value below it. So first row of zeros, there will always be, right? Then A is equal to 3 plus 0. 3 plus 0 is 3. So A is 3. Now I'll have to get this. I'll have to increase 15 left of it plus 3, the A that I just got. So it will be 80, right? So the next value of the first history is 18. So for this input, I'll get 8. So next value, 15, finding all zeros different. This is a bit different. We get, instead of 3s in the first time, we get 2, 3, 4, 5, 6. Then we get 1, 1, 1, 1. And we get 3 zeros. And we do the same algorithm. Here is a bit different. It's 3, 3, 5, 9, 15. So, and that's 2s, only 2s, and again, doing the same thing. So the next value of the third history is 68. So we have 28, 68, and 18. If you find the next value of each history in this example and add them together, you get 114. Analyze your Oasis report and extrapolate the next value for each history. What is the sum of these extrapolated values? This is what I got, and let me show you the input quick. Actually, I have it in Studio. Okay, this, where is crash maintenance? Okay, this is one sequence, and this is another, and I have 200 sequences. Right, I have to. So 200 sequences, right? And I have to do what they told me at each sequence. So that was actually pretty easy for me. I know, I think it's because of the approach it shows. Got lucky. But hey, I'll take it. Do I have any classes? I don't. Why? Okay. Parsing input is uh, really easy. I have vector vectors, so basically a matrix, but basically each vector is or each vector is this. So this is a one vector, right? And each value in this vector is basically, this is the first value, minus 7, 4, 41, 121. So I have vector vectors. This is basic parsing I don't know how it works. I just do it. Open Mirage maintenance. It is open. I actually have to visit. File close. Okay. Now, basically, I'm doing get line. Creating a vector that will represent the current line. Hence, like the inner vector like this, basically. I'm going over each character in current line. If it is an empty space, then current history. So that's current line of numbers. Push back current number. So current number, I'm adding the character of current line until I find space. So I have first will be -7, minus, then 7. So this will be string. Here I am when I find this, so empty character or base, sorry, or however you call it. Then I am pushing back stoi, string to int of it, of the current num, and I'm clearing it so we'll be ready for the next number. I'm going through the whole line. Here I have to push back again a number because I'll be reading this, for example. So I'm adding these characters to current number string, and it ends here. So I don't have space or an empty character, so it won't go here. So instead I'm doing that at the end. And then I'm pushing in values, the vector that I just created here. And Mirage maintenance file close that I just did. Okay, so this is the right. So I'll go over this when I get to part 2. But for now, basically, yeah, I don't. Hmm. Follow you. Okay, that was actually kind of a bug here, but they were really basically the same. So, anyway, this is the method, the function I'm running at main. It will execute all the code of the other functions I built. So I'm building the history. So basically, putting all of this into vectors. Parse input, right? Sum, so the sum of all those added values in the sequence. And here is values. So which vector in history, so for each line of values, I'm adding sum, and this is basically calculating the value at the end of this vector. What does this do? This is this is most of the logic in basically all of the logic in program. So first of all, this is recursion. I did this with recursion. So I'm creating boolean are all zeros. Um, okay. If all my values are zero, this is my exit. Exit. This is when I'm stopping the recursion. Okay, forgot the name of it. So if I'm going through all the values in my vector, if value is not zero, then not all zeros are not all values there are zeros, and I'm breaking. But if I didn't go here, I went over the vector and I didn't. I mean, all values are actually zero. Then I'm returning zero. Now, what do I actually return? If you remember, I have like a sequence of numbers, right? Say 1, 2, 3, 4, 5. Right? I have to find this value, right? And I have now 1, 2, 1, 1, 1, 1, 1. Okay. And here I have 0, 0, 0, 0. Okay. So basically, when I'm here, I'm saying return 0 to here, right? When I'm here, I'm doing something a little bit different here, but basically I'm saying return whatever I got from here, minus. First one is doing it. Calc. Okay, so this is the second part. I think it will work without the function. I just uh anyway. So this returns 0 here. It will do actually it will do 1 plus 0. So I will get 5. That wait no. 1, 2, 3, 4, 5. 1, 2, 3, 4, and this is 1, 2, 3. With 0, this is a. Okay, so it returns 0, 0, and a is actually 1 plus 0, so this will be 1, and this is 5 plus the value I just got from a, so this will be. And this is the recursion. So I get here, I return here 0, here I return whatever returned here, plus this number, and again when I get to the end, I just turn 6. So go. Yeah, and it. Wait, I got myself confused a bit. Here I go. Value return values. Next. Okay. So, and basically, I'm returning the 6, right? So, what I do in this, I'm creating a next values. So the next one, again, if I was 1, 2, 3, the next will be 1, 1, right? So I'm going from 1 because I have to first. First thing I do is um, it. First thing I do is subtract like the index 1 from the one index 0. No, sorry, subtract index 0 from index 1. So yeah, so this is 1, this is will be values at 1 minus values at 0, then values at 2 minus values at 1, and so on. And this is my new vector, what it told me to do, track those values. I'll end up with a vector that is small by 1. So I'm currently here. So basically, this is basically, if I put here false, it will do part 2 basically. But when true, so it always get here, always be here. It's good part 1 and never get here because it's always written. So I'm returning values at values size minus 1, so the last number, right? And 1 to 3, the last number is 3 plus whatever this uh, whatever this gives me. Okay, so at the end it will be here, it will give return a 0, then 1 plus 0 is 1, then this will return 1, at 3, right? 1 to 3, so it will return 1 here. This is 3, so it will return 3 plus 1, which is 4, and this is actually the number in sequence of 1, 2, 4. That's it for part 1. Let's run it. Oops. I'm running the Mirage main name. Oops. Where's main? Okay, so let's run it. What? Fucking weird. Why did I change? Do I have to bring it back? I guess. 0, 0, 0. Am I using the correct one? Oh, Jesus. I don't need this. So calm. I'll. Okay. It gave me the address to this function, I think. Okay, and let me share you my screen. So this is the number I got. Execution time is 1 millisecond. Millisecond, yeah, 1 millisecond. And yeah, this is. I'm comparing it now. You can remember this number. day 9. This part 2, it's actually very, very um I know English, forgot the word. It's very, sorry for the brain fart. This is basically the same, just from the other direction. You'll see. So of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely zero. Then, rather than adding a zero to the end and filling in the next value of each previous sequence, you should instead add a zero to the beginning of your sequence of the zeros, then fill the new first values of each previous sequence. In particular, here is what the third example of history would look like. So we're going now this way. So 2 minus 0 is 2. Then I'm going 0 minus 2 is minus 2. Then 3 minus 2. What? Sorry, 3 minus minus 2. So it gave me minus. Supposed to subtract this from this. So 3 minus minus 2 plus 2. So it's 5. 10 minus 5 is 5. So this is what I want for my sequence, the number. Adding the new values on the left side of each sequence from bottom to top eventually reveals the new leftmost history value 5. Doing this for the remaining example data above results, the previous values of minus 3 for the first history and 0 for the second history. Adding all three new values together produces 2. And your research report again, this time extrapolate the previous value for each history. What is the sum of these extrapolated values? This is what I got. Actually, much, much less than the previous one. But yeah, so as you've seen, this is exact. That's the almost the exact same as the previous. But here I just go from here to here, and here I go from here to here. Now, I think if I wouldn't have used version here, would be much it would be much harder to solve, I think, because now I was doing it at the front, now I have to do it here and go this way and not this way. I don't know, it would have been hard. I didn't do it that way, so I don't know actually. It's hard or not. I just did the recursion way. So I actually didn't change almost anything. Um, actually, but just so in here, my initial when I first solved part one, I didn't have this, right? I just returned this. So if I switch this line of code with this line of code, it will give me the answer for part two. I did something a bit different. I just added the if in this line so I can go between part one and part two. The good thing I did that because now I don't have to rewrite this or a new function for which will do basically the same with just this little difference. So yeah, the recursion way, I just have to use switch one line of code and this give me the answer. So if you remember, it was 1019, right? So basically, instead of returning this, I'm returning switching this false. Okay. Yeah. And I'm returning values at 0. So now first value, right? Minus this. I'm calculating the next first value. So it will be 2 minus 0 there. That's 2. And above it, it was 2 here. And return 2. So return no, it was 0 and this returned 2, so 0 minus 2 is minus 2, and then I had 2 minus minus 2 plus. Okay, that's basically the same as this. I just take the 0 instead of the last value, so the first value instead of the last value, and I'm subtracting from the I'm subtracting this from instead of adding it. Let's run it. And if you remember, it was 1019, and as you can see, it is 1000 here. So that's 9. That was question 9. Now, question 10. Absolute pain of existence. It took me yesterday and today, basically. I finished it today. So, close those. And uh, pipe mates. That was pipe. Any dish. Whatever. Let's go to day 10. Event of code. Uh, okay. But this. Oh, it actually captures the whole screen. That's nice, but I'll have to deal with those things outside of the border. I know how to fix it, okay? I'm sorry. Um, I mean, I just did, but it was had to go full screen. It's not really. Don't like it. So let's wait. Day 10, pipe maze. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. This island is surprisingly cold, and there definitely aren't any thermals to glide on. So you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you occasionally find signos, signoposts, signposts. I don't know how to fucking read. Labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in peripheral vision and jump into a big pipe. Didn't look like any animal you've ever seen. Sorry. Cables from my headphones are very long and super annoying to don't make them fall on the floor and basically step all over them again and again until they aren't usable anymore. Right. Okay, where was I? And then jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all of the surface pipes you can see your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. This is actually called the pipe, I think. The pipe is a vertical pipe connecting north and south, minus or horizontal pipe. L is a 90-degree bend north and east, so that for you. L, J is like L, just different direction. 7 is up and left. I'll go with, if you don't know, south and west. So F is down and right. Dot is ground. There is no pipe in this style. S is where I start. There is a pipe on this style, but your sketch doesn't show the shape pipe has. This is actually my code of this uh, of day 10 is actually very fucking rough. It works, but I hate it. And we'll get to this is one of the reasons, but one of the many reasons. Based on the acoustics of the animals carrying, you're confident the pipe that contains an animal is one large continuous loop. For example, here's a square loop of pipe. A square loop pipe is a square loop of pipe. So yeah, so we go from here to here, down, down, left, left, up, up, or down, down, left, so down, down, right, right, up, left. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. So if he entered here, this is S. So we can deduct this is an F because it's connected to this and this. Um, in the diagram, actually, you say, what if this is a minus, say, and this is also a pipe? I checked all the samples and the input. It always connected to two pipes, so there's only two exits. Um, so like the input maybe here a minus, so I can't go from here to here because I need something connecting me. Gotta be a 7 or a pipe. In the above diagram, the S style is still a 90-degree F bend. You can tell because of how the adjacent pipes connect. That's right. Unfortunately, there is also many pipes that aren't connected to the loop. This sketch shows the same loop as above. So this may be a bit confusing here, but I'll walk through. So this goes right, right. This is starting. So right, right, down, down, left, left, up, up. Oh, that's the same. So yeah, we have a 7 here, but we never got to it. This is not part of the main loop. So the main loop just basically starts from S, goes somewhere, and ends on S. And there may be some pipes that aren't connected to it. There may be loops, but without S in them, it doesn't count. They're still not connected. So in the above diagram, you can still figure out which pipes from the main loop they're the ones connected to S. Pipes, those pipe S pipe, those pipes connect to pipes, those pipes connect to, and so on. Every pipe is in the main loop connects its own neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. Oh, that's what I said. I just didn't remember reading it. Here's a sketch that contains slightly more complex main loop. So right, so right up, right down, down, right, down, left, 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 down, left, up, and we're here's some example sketch with the extra non-main loop pipe tiles shown. So this is the same loop, but we have like this here that is not connected, and those that are not connected. This I think. If you want to get out ahead of the animal, you should find the tile in the loop that is furthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop. Reach from the starting point, regardless of which way around the loop the animal went. In the first example with the square loop, we can count this distance each tile in the loop from the starting position. So, what is he saying? So, I'm not gonna find the closest space to this because these are either this or this. It's a one. right? But I am not counting on which direction went. I will take the furthest point from this loop to get from either direction. So if I go from here, the furthest will be up here, right? So it goes all the way here, and the furthest point this. And this is the far point from this. But I'm gonna end. I want this because this is the furthest point from here and here. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4. If I take this, for example, I have 1, 2, 3, 4, 5. So this is further, but this is only 1, 2, 3. This is less. This is less. So I want to first point one of them, and it's supposed to be the same number. So you can count the distance each tile in the loop is from the starting point like this: 0, 1, 2, 3, 4, and 0 first, 2, third step, and fourth step. In this example, the first point from the start is 4 steps away. Here's a more complex loop again, so this, and if you go here, it will be 8, and from here it also will be 8. So first part, find a single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point furthest from the starting position? Okay, let's go to the abysmal code I wrote. That works at least, okay? That's something. So, um, use this first part also. Yeah, I did. Actually, I created a tool. I created a matrix, basically a class or struct. That was struct matrix. But instead vector or vectors, I'm using a single 1D vector. Some calculations, I know what row and column am I, even though I have just one big row, but I know how to turn it in. Let me show you. I also played with templates, but I still don't understand them really well, right? So this is tools. I just need a vector, at least for now. Maybe I'll add something later. And struct mat. So this is my matrix basically. Here I have the main matrix, so I'll store it and type t. So basically, I'm just saying you can store it whatever you want. In here, I have column size that I'll get from I have to get because I know like how wide this is, right? Otherwise, how do I know when to, you know? So at the constructor, I just saying column size. I pressed a button. I'm saying column size, initiating, okay, initialization list. So here I have a method that returns t, so the type that the vector is holding at. So basically, I'm just this returns. I'm giving it I and j. So what this I is what row, j is what column. So at row I at column j, I'm going to return the value. So this basically is equal to I times column size plus j. This works. I can go over it, I guess. It's like okay, you have I, right? You have a row. So I say first row. So this is 1 times column size. Now say I have 3 columns, okay? Now I want, let's say I want at, so at the middle, yeah, at the middle. I1 and the J1, okay? So in my vector, it will be 0, 1, 2, 3, 4. Will be in the fourth place. So my column size is 3. So I is 1 times column size is 1 times column is 3 plus 1, that is j. Now this works because like I'm taking a row, I'm saying which row it is. Okay, in this row, basically multiply I have fourth row. So it will be then I'm gonna this issue. So I have say this is this is my matrix, okay? 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, to turn it into a matrix, this is a vector, right? To turn it into matrix, this is my first row, this is second row, this is my fourth row. And this, this, this is my first column, and again, this and second is my second, and here's my third column. So I'm taking the I, so we said at second row times column size. So I'm taking this, right? This is first. There are 3 of them, those values. I'm multiplying by amount of rows I want to get. So I want to get to the first row, I'm multiplying it by 1. So, right, if I want, um, I multiplied by 1, by 3, sorry, 1 by 3 is 4. So 0, 1, 2, 4. I want first 1 times 3, sorry, 3. 1 times 3 is 3. So I'm taking 1, 2, sorry, 0, 1, 2, 3. And as you can see, this is the first row. So the row at index 1. And I'm adding the j. So those 3 are current row, and each of them are their own column. So as I'm saying, second j. So this, I'm going to add 4 plus 2 will be here. So this is row 1, column 3. And that's how this works. So I have this, I have set, I am giving it again ij, and so I'm changing a value here, and I'm giving it eval. So again, based on what I have in the matrix, and basically the same, but at this the matrix at this place is now equal to val. I'm not returning anything. I'm just saying it equal to val value. Pushback. I'm just because this is private. I'm just doing pushback on the actual length. Now, didn't that? Oh, sorry, that's right. This is the length of so we have a width, length. So length, I'm rounding up matrix size. Um, so sorry, rounded up, I have a size of I have some matrix. I'm taking the whole size of the vector, and I'm adding here values until it is divisible. Sorry, until column size is divisible by rounded up. Then I'm returning rounded up um, divided by column size. Yeah. Anyway. Uh, oh, hello, Steve. I no see. I can fix that. Yes, sorry for that. E- um, is it better? How long is your comment here? I didn't see it. I was going over this. Hope I didn't miss you, lose you. I can do I have high noise suppression. I can. Is this better? I'm trying to figure it. This is the settings. I just have high volume suppression because sometimes I have noise in the background. Uh, uh, Also, I can go this. Is this better? Also, I think I just speak very uh, on a very low volume. I'm just like that. I hope it's fine. I can make some other changes if needed. That's a lot, but I can manage. How did the rest of day 7 go? Day 7, that was some time ago. I did finish it. What was day 7? Um, where was it? Camel cars, right? So I have. What do I have? I already forgot. Um. Oh, I had a couple bugs here. I had to change. This is basically it. Um. So just a couple of edge cases, and I was able to finish this. Um. I I don't remember really well. So if I have same suit, one of the same suit, and my hand at J is one, so this is what you told me to do, right? Because I have now a pair. Because I have one J and all are different, so I have one pair. Same suit. If same suit is equal to 2 and J is equal to 1, so I have one joker. I'm actually reducing the amount of pairs by one because now this causes me to have let me show you. I think that was 2 2 1 3. Okay, there are 5 cards, right? So this is supposed to be 3 of a kind, but it counted same suit 2. It added, so it counted one pair, and 2 was the highest, so it actually said I also have 3 of a kind. So I counted this, that's just supposed to be 3 of a kind, as a full house. And so if I do have this, I am reducing the amount of pairs, so I won't get full house here. And this is the same here, right? Yeah. And that solved it. Actually, going over day 10. I did 8 part 2 and 9 off stream. I wasn't able to stream. And 10 off stream. I finished today though. And now I'm streaming this. That's the pipe maze. Um, oh yeah, I was going over my. I built a little matrix struct that can handle any type. Just basically the a metric set I times column size plus j. I just went over it. Like I'm grabbing. I mean, I'm putting it inside a vector, 1D vector, and with those fun methods, uh, I am able to manipulate it as it was a matrix when I pass in the I and j. And the length actually what I didn't hear. So yeah, I need to round up all. So I have a square basically, matrix and then return the length. Um, there's definitely a better way, but it also worked. Okay, so now pipe maze thing. Parse, I think, is the parse is easy. I am just using the matrix I created, and in here I'm just and in the current line, like I'm doing stem get line, current line each character I'm pushing here in the matrix, and closing here. Okay, so calc steps. This is the first part, right? The first part was just calculate the closest, the least amount of steps I have to take from each side. I'll basically go from each side and see how many steps take them to meet. That's what I did. I think I can just take a whole loop and divide by two. Maybe add one if there's like I don't know a rounding problem. So this here I am parsing an input. First line, what do I need? The first line or the forgot? The first line I need to understand what amount of columns I have in my input. Input. Okay. The pipe mistakes. So I just need this number of. I mean, the length of this, and so yeah, and I'm creating a new matrix with this size, with this amount of columns. Parse input. Now, I starting position. This I think I can go without the zeros, but Visual Studio is mad at me for doing this. I don't know. And I'm creating. I have a struct for agent, or is it? Yeah, I have a struct for agent. So agent is basically sort of a simulation that will go over the um just going over the maze. So I'm calling it agent, whatever on the maze. I'm storing here current position and previous position. I'm storing here previous position. I don't know why it's mad at me here, but it's a green one. At least it's not red. So sorry, I have some noise here. I'm gonna close the window. Just a second. Louder than me. I'm sorry for that. I hope you can't hear it now. Uh, okay, so current position and I need previous position to understand which way I'm supposed to go. So, uh, thought maybe you had pet bird. No, those are children playing outside. I don't. I have a dog. Um, actually, now I want a pet bird. I'll probably buy a pet bird sometime. A parrot. Parrots are cool. Uh, so yeah, I need to understand from where I came, so I know which step to take. Because at 7, I can go uh, down or right. And if I came from down direction, then I have to go right. So this is agent. I called it agent. I don't know why. Sounds cool. So I have two agents, each of which will go a different direction. I'm going over the matrix. Why do I need a flag? I don't remember. We'll see now. So I'm going IJ on the matrix, and stop it, stop it. Well, I can't break the I from here. Yeah, this is why I did that. I probably can somehow. I don't know how. So I use the flag. So if I find my starting position, I am updating it. So my starting position is I and J. Now this is a part I really hate about my code. Um, so the starting position is basically depend. I'm not giving them to start on the same tile. One will start the next tile from S, and the other will start from next tile to S in the other direction. So I have to change those two and those two values each time I go through different. Uh, this is actually for my input. If I go and check on a sample, I have to change this, or another input, I have to change this. I know I can check around and determine what kind of tile S is. I didn't do that. It was, I don't know, I thought about it was too annoying to code in. Um, I know how to do it elegantly because I have to go just a lot of if else statements it'll take, I think. Um, so yeah, not sure. I mean, probably can do it somehow, but yeah, I'm not doing that. Okay, so I have now I'm updating his previous position, which is the start position. Also, his previous position, the second one, is also the start position. And here I have while true. I don't like doing while trues, but it, it doesn't go into an infinite loop, so it's fine. Now here I have moved to the next style. Move to the next style, accepts I, J, the matrix. Um, Probably should be const something here. I'm not changing anything. Um, Besides the previous I and previous J. So now I have I direction and J direction. So basically, if I'm moving up, I will decrease by one. If I'm moving down, I will have to increase by one. And I'm just doing a bunch of checks here. So if that's a pipe and my previous I is less than my current I, then I'm going up. Sorry, I'm going down. It's inverted in matrices. If not, then I know I came uh from here, so I go up. The minus is the same just for J, so if I came from left, then I'm adding one. If I came from right, then I'm yeah, that. Um L is if my I stayed the same, so I just I st- hmm, if my previous I, so I came from here, right, from above. Um I came from above, now I want to go right. So I direction is minus. Why is my I direction is -1? Uh, it works, I swear. Uh, I don't know why, but it works. Okay. um, if it is the same I, then I have to go right. I'm actually going back up. My I is by the way the up and down. Uh, it makes sense when I looked. Wait, let's look at the input. Oh God, what was it? L. Okay, L. So Okay, if I come from here, my I just changed, so I need to change my J, isn't it? I directions minus. I did this by the way on all of those, right? Previous I is equal to I, and I direction is minus one. If they are not equal, then my J direction is changing. So yeah, I'm going left. So if I came here, yes. Actually, I did it the other way around, but it didn't work, and I changed it, and then it works. So here I'm adding to the I and J my directions, and updating the previous ones to the current ones. Now, why does it made sense? I swear. Okay. From 7 to L, does my I change here? 7 to L. If the I are the same. Oh, it's right. If they are the same, got it. I got what I wrote. I understood. So if the I are the same, then I want to go in the direction of like update the I, right? So if the I are the same, I moved in the J direction. And if the J is the same, I move in the I direction. Okay. A brain fart, but I got it. Okay, so and same for J7, just different directions. And here again, I'm updating this and adding the direction. Okay, so that's it. So we're here now, right? So um yeah, I'm moving the first agent in whatever direction it needs to go, updating it his number of steps, then I'm checking if first and second agent are in the same on the same tile. If so, then I'm breaking and returning the amount of steps. Then I'm checking the same. Then I'm moving the second agent, and again I'm checking if they're in the same place. So I have to check after each move. And returning this, and well, that's it. Let me run it. It is called pipe maze. Pipe maze, and that's maze. And the calc something I don't remember the name of. Calc steps. Okay, running it, and it takes 3 milliseconds and gives me 7063. This is the answer. Yeah, that's the correct answer. So yeah, I'm just counting the amount of times one agent took a step. Oh, sorry. Yeah, I'm counting the amount of the first agent steps, but here I'm also checking if they are after moving it, moving the second agent if they are on the same tile. That's the first part. Second part is much fun. It's much more fun. Let me change back, and I'll read it again. I was able to solve it, but it was. I first of all I had a hint. I couldn't do it without the hint. So um, you quickly reach the furthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, I have this loop. The above loop encloses merely 4 tiles. The two pairs of dots in the southwest and the southeast marked I. The, the middle dot tiles marked 0 below are not in the loop. Here is the same loop again with those regions marked. So this and this inside the loop, those are outside. Now, at first I didn't understand what exactly meant inside and outside, but basically I'm taking I'm taking the path of the main loop, and actually the reason this is outside because like if there was it's closed on itself, so it never it's not supposed to be loop. It's like outside the loop because it goes like, like that. I know how to explain it. I understood it, but no, not sure how to explain it. I visualize I visualize it as one squiggly line. So yeah, that'll be outside the loop here. In both of the above examples, four tiles are enclosed by the loop. There's a large example. Now I'm not gonna go through it, but basically this is inside the loop, is outside, and all that. Eight tiles by the loop, enclosed by the loop, and tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example with many bits of chunk pipe lying around that aren't connected to the main loop at all. Now here we have bits of chunk. Um, so basically these are tiles that are inside the loop. Also we have, uh, I'm not gonna come, but we have some pipes that are not connected to the main loop. Um, so this is 10 enclosed here, and I have to figure out how many tiles are enclosed in the loop. Fun. Uh, I'm gonna go to my Visual Studio. Okay, so calculate enclosed tiles. First of all, I'm doing the same I did in part one. But here I'm doing not counting steps. I am outlining my main loop to differentiate between my pipes that I care about and the pipes that are just there. So I've my first and second agent. Again, I can do it with one, doesn't matter. Same logic here. Um, so main loop tiles. Here I remember what tiles are part of the main loop. So first of all, the starting positions and the new position that the first agent went to and the second agent. So here again, I'm just going through the loop, and here I'm adding each time if they're on the same tile I'm breaking, uh, then I'm pushing back wherever he is. Then I'm doing the second one, again checking, and then I'm pushing back wherever the second agent is. Okay, here I go through all of the map basically of pipes and replacing. So if I don't find if I find the current coordinates in my map, then I'm continuing. Like I don't execute this basically. If I don't find, that means current tile is not part of the loop. So whatever pipe is or tile, whatever, I'm setting it to a dot because that's not necessary. I think. Yeah. I'll comment it down. If something won't work, I'll bring it back. I haven't pushed yet to GitHub. I probably should do it more. Okay, so I'm going through the matrix here. Again, that's the main logic, I think. What do I have? What- Did I? Oh, okay. Here, whatever is on the outside layer of the loop, I'm turning into zeros. Okay. I don't remember exactly why I did that. I think I can. No, no, I remember. I remember why I did that. I'll explain later when I get to there. Okay. And again, I'm running on a matrix, so that's not one of the most. It's not one of the best solutions, probably, but it works at least. Okay, so I have a boolean of is inside. By the way, that's I'm gonna go through the algorithm now. What I actually want to know. So let's open the sample here. Second, I'm adding the sample. So yeah, basically, if I see a pipe, so I'm going starting with I'm outside now, right? I see a pipe, then I know this is inside. Then I see another pipe, this is outside. I don't see anything. So whenever there's a dot, I know the dot is outside now. Then this is inside, and this is outside. There, so this is inside, right? This is outside, inside, outside. Now, this is the basic algorithm. There are some caveats here because of how it's structured. For example, um, let's say I have what was F and 7, I think, right? No, not F7, F and J. Right, so F and J are basically, I can't draw here. But basically, if we just draw the shape of how they go, so it'll be like F goes upwards, right? Oh my god, do I have to do this? I'm gonna draw it, okay? Let me open Paint. Okay, so F and J, right? F goes from F goes this direction and this, or or from here to here, right? And J goes from here, here. And if I draw it as part of the loop, as part of some track, so it's actually looking like this, right? Very badly drawn, but this is so that we have this loop. So this is basically like this is L, right? Right. This is like this. This is J. This is a pipe. From here to here is a 7. This is 7. This is F. Another pipe. Not pipe. Sorry. This is J, and this is F. Now the problem here that I want to go from here to here. Now this is inside the loop. The problem is I only want to count it once. So like I'm outside, oh, I'm inside. But because it's FJ, I'm actually counting I'm inside and I'm outside. So when I see F and J, I have to count them as one, like switch the state. So I'm inside and outside. What I did is actually when I see say F and 7, so this is basically this shape, right? So I see F and 7, I just don't switch because I was outside, now I'm inside, now outside. So I actually didn't change the state I was in. But if I see F and J, I do change the state. Okay, back to the code. Um, okay, so I'm starting with outside. At the start I'm always outside, right? Because I'm at the previous pipe. I need to remember my previous pipe so I can compare F to J and all that stuff. Um, so I'm starting with J equals 0. I'm initiating it here because I'm using the loop twice. Like I'm gonna end this loop at some point, and then I want to continue from the same place here. So while I'm not a dot, minus or 0, previous pipe will be. So I'm dating my previous pipe to the first pipe I see, basically. I see a first pipe, then I know I'm touching the loop now. And my previous pipe will be the first pipe of that loop. Then I'm starting from J I just left here. I'm breaking it because I'm picking from the same place, going through my column size. So basically the row, it's columns, but technically I'm going through the row, right? So if matrix at ij is minus, I'm actually just continuing until I see another pipe. That's because let's say I have uh, f. Oh, sorry, let's see f. I'm stupid. F bunch of horizontal horizontal pipes, and then I see what was that? That goes f7, right? So this is all technically inside the loop. So it can be 5, it can be 4, it can be whatever number. And I don't want to change each time I see this because it's part of this. So I'm going inside and then I'm going outside here. Now, still, if I have 7, F, and J, I do want to switch here. Not at not at everyone. Basically, want to erase those. I don't care about those, but I'm not really erasing them. I'm just continuing. And here I know, okay, I have F and J, so I'm gonna switch my state. Also, there's pipe, so here I do switch my state. I know if I'm crossing from here, I know it's not connected to anything. It's like it's a wall, so I do have to switch my state. My previous pipe, again, it's current pipe, and I'm continuing. Now, if I find an L and a 7, so my previous is L and then 7, or I find F and then J, then again I'm switching states. And my previous pipe is now my current pipe, and I'm continuing. Else if it is a dot and I am inside, then I am counting it uh, as an inside, as an enclosed tile. And previous pipe is now matrix at ij again. So with all those continues, I'm not gonna reach this. So I'm not going to do this multiple times, right? Actually, I don't have this. That was to print the, and this works somehow. Uh, yeah, I'm gonna run it. It's a little bit slow. It's like 70 milliseconds. I say a little bit. I know 70 milliseconds is not that slow. Just I don't know. It's more than 9 milliseconds. Um. So yeah, basically that's it. So if I do see L and 7, then I'm changing my state, and if I see F and J, then I'm changing my state. And I'm keeping on going through. So let's run this. This pipe pipe maze, calc steps. This is gonna be. This is it. Oops. Calc enclosed tiles. It's on release mode and run it twice. Yeah, 50 milliseconds. And this is the result I get, 589. And if we go back to day 10, it's 589. That worked. That was fucking hard. And I'm sure I can make a lot of adjustments here. I can start with the S thing that I don't have to change between inputs, but it works at least. Um, so that was days 8, 9, and 10. Um, actually, I'm almost 2 hours in. If 11 is hard, I'd rather do it tomorrow. Is 11 hard? Do you know? Is 11 hard? I haven't read it actually. You know what? I'll go through it. I don't. I'm not promise. I will not promise I'll actually try it, or maybe just part one. Maybe. I'm gonna read it at least first. Okay. Okay. So cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using a giant telescope here. He doesn't know anything about the missing machine parts, he's only visiting for these research projects. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of what I was okay, bunch of oh fuck. Yeah. Uh, okay, I have half an hour. A bunch of data and compiled the data into a single giant image. Your puzzle input. The image includes empty space and galaxies. Emphasis is a dot and galaxies are sharp. For example, this is a galaxy. Wait, the image empty space and so this is a galaxy and this is space, I guess. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expands in the time it took the universe expanded in the time it took the light for those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any row or column that contain no galaxies should all actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. Okay, so this. Okay. These rows and columns need to be twice as big, the result of cosmic expansion. Therefore, it looks like this. So we have now 2 rows here. 2 columns and 2 rows here. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. In these 9 galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find any shortest path between the 2 galaxies using only steps that move up, down, left, or right exactly 1 dot or sharp at a time. Shortest path between 2 galaxies is allowed to pass through another galaxy. For example, here is one of the shortest paths between galaxies 5 and 9. So like that. This path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. The 8 locations marked sharp plus the step onto galaxy 9 itself. Here are some other examples that show the path lengths between galaxy 1 and 7, and 3 and 6 is 17, 8 and 9 is 5. In this example, after expanding the universe, the sum of the shortest path between all 36 galaxies is 374 pairs of galaxies. So, wait, it's pairs 1, 2, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. That's pairs and then all gone. Okay. Next example, after expanding the universe, the sum of the shortest expand the universe, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? I have 20 minutes, so I'm gonna sit on this for 20 minutes and then we'll see. So first of all, the expansion part. Uh, this is quite annoying actually. I need to insert inside of it. I can use my matrix I built, but I don't know. Hmm, not sure how to expand the universe. So the problem is after I expand the universe, I need to also not wait. If I have two empty rows, then I have to add another two. Uh, why no? I'll create a matrix. I'll add everything up. Okay. Then I go from right to left. Yep. That's not it. Um. Yeah, I definitely don't have the brain capacity for 9, so I'm sorry. I'm not gonna. I'm not gonna do it today. Um. I probably try to do it tomorrow. I'll actually think about the question, maybe have some ideas before I stream. So I'll probably end for now. Um, oh, sorry if the microphone is off. I hope I made it fine. I'll try to configure it more before the next stream, or maybe speak loudly. I don't know. We'll see. All right. Thanks everyone for watching. Um, that was fun today. Day 10 was fun. Day 11, I'm not sure how to do right now, but think of something probably. And yeah, everyone, thank you everyone for watching, and bye bye.